Hey guys, it is time for the wonderful world of inscribed angles, section 12.3. Prepare yourself for a lot of theorems here. The first thing, and we've talked about it a little in our graphic organizer, is an inscribed angle. And it's an angle whose vertex is on the circle and has two sides that are chords. All right, so what we haven't talked about is that intercepted arc. The point at which the two sides of the inscribed angle hit the circle. So if I were to draw that out over to the side here, and this would be my inscribed angle. Right here, let's say it was BAP. This arc, BP, would be my intercepted arc. Okay, so Theorem 12.1. The measure of an inscribed angle is half the measure of its intercepted arc. So, right here, whatever this arc is, this angle here is going to be half as much. So the measure of angle B is always half as much of this arc. That's what Theorem 12.1 states. And this is a corollary. Word that I'm so not fabulous at pronouncing. Sorry, I don't know what happened to my whiteout there. Alright, so you have two inscribed angles that intercept the same arc. That means that they would be congruent. So if you see, I went ahead and drew an angle and highlighted in pink, and it intercepts this arc right here. Well, although this angle right here, B, that I highlighted in purple, is in a different location, it intercepts the same arc. So as a result, the measure of angle B and the measure of angle A, or A and B, would be congruent. They'd be the same. And here's corollary number 2. An inscribed angle in a semicircle is a right angle. So a semicircle, you guys, we already know that that's half of a circle, okay? So if you have an inscribed angle right here and it intercepts your circle at the semicircle, then you know that that angle will be 90 degrees. Keep in mind, it's 180, right? So half of 180 is 90. That's corollary number 2. Okay, so corollary number 3. The opposite angles of a quadrilateral inscribed a circle are supplementary. So that means if you added angle 1 and 3 together, they would equal 180. And if you added angle 2 and 4 together, they would equal 180. The opposite angles of a quadrilateral inscribed in a circle are supplementary. Okay, let's talk about this. Theorem 12.12, or 12.12. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So here's our tangent, and here's our chord. This angle right here will be half of this arc. So almost like an inscribed angle, but this time it doesn't have to be really an inscribed angle. It's a tangent and a chord. It'll always be half as much as this arc. And the same goes for right here. Here's our tangent line, right? Here's our chord. So this whole arc right here, whatever it is, you would cut it in half to find this angle down here. The measure of angle C is going to be half the measure of arc BDC. This is an example I would like you to write down, and we'll go over it more in class on Thursday or Friday. So line ST is tangent to this circle at point Q. So here's ST. Not sure why I wrote SR. ST at point Q. If the measure of arc PMQ, so this whole arc right here, equals 212, what's the measure of angle PQR? This angle over here. So if we know that this arc, PMQ, this arc right here, is 212, what's the measure of this angle right here? Anyway, all right, guys, have a good night. I'll see you later.